Hello everyone, welcome back to the Nature Research Academy's online webinar in Systematic Reviews and the Meta-Analysis Workshop in partnership with the Egyptian Knowledge Bank. My name is Hala and I'm going to be facilitating this webinar. I will be helping Dr. Jeffrey Robbins to run the polls and exercises, and I will be chairing the Q&A sessions. Also, I will be helping anyone who's having any technical difficulties. So now I will hand over to your trainer, Dr. Jeffrey, to get started.
Thank you so much, Hala, and I'd like to welcome all of you back to the second of two webinars focused on systematic reviews and meta-analyses. So in the first webinar, we talked about the importance of systematic reviews, how to identify a good research question, how to identify the good studies, a good selection strategy, the screening process, and data extraction. Now in the second webinar, which is still part of the same workshop, we will now move on to talk about how do you rate the quality of evidence. We talked about this a couple of times in the previous webinar during the Q&A. Some of the studies you evaluate will be more technically rigorous than others. How do you assess which ones are good, and how does that factor in, and how is that displayed or presented in your actual manuscript? We'll then talk about some meta biases. These are biases that may affect how you conduct your systematic reviews. And then finally, at the end, we'll be talking and comparing qualitative and quantitative syntheses when you're presenting your evidence. So let's now move on to talk about rating the quality of evidence. Now, for those of you in clinical research are likely aware, there are many biases that can affect the technical rigor of that study. And so as an assessor, as a reviewer of these studies, you need to be able to detect that type of bias. We all know these types of biases or limitations. A variety of studies will have different biases and limitations. That's going to then affect the outcomes of those studies. Well, from a systematic reviewer's perspective, you're coming from the other end. What you're doing is you're assessing these outcomes and then trying to evaluate what kind of biases these studies had. So it's almost a reverse engineering of those different studies. And you do so, we call it assessing the quality of evidence. In other words, how trustworthy, reliable, accurate do you think this data that you extracted actually are? Now, the most common way that people will actually evaluate quality of evidence, getting back to Cochrane, is the Cochrane risk of bias. They have a nice evaluation tool where it's basically presented in these types of circles, like almost like a stoplight. Green is good, means a low risk of bias. Yellow means it's an unclear risk of bias, and red means it's a high risk of bias. And there's a variety of different parameters that you're expected to evaluate each of these studies on. And then what you would do is you would present this graphically, visually, like this. This would be a figure in your paper. And so, for example, there's items that are related to selection bias. There's going to be items related to performance bias. There's going to be an item related to detection bias, one for attrition bias, one for reporting biases, and then finally, any other biases that you felt those studies may have had. So we're going to go through each of these and explain, give you some examples of high risk, high, low, or unclear risk of biases for all of these different parameters in a moment. In addition to this, what you can then do is then compile all of this information together to actually have a risk of bias graph. And this is often, again, what you'll see presented in systematic reviews and meta-analyses, and allows you to be able to see over all the studies they evaluated, which ones that those reviewers felt had high risk or which dimensions had a low risk of bias. So we can look at this, for example, this meta-analysis. We can say in the studies that were evaluated, there's very low risk of bias in terms of sequence allocation, either blinding of participants or personnel, or the outcome assessor, and as well as outcome reporting. But there was a very high risk of bias in terms of allocation concealment, and a potentially high risk of bias for incomplete outcome data, so attrition bias. So it's a nice way to kind of have an overall summary, and that lets us know, okay, well, if attrition bias was an issue, there was a lot of missing data in these studies, then allows us as a reader, when evaluating this work, the systematic review of how much we can actually trust the reliability of this information. And hopefully the reviewers would emphasize as a limitation in their systematic review. They had two key limitations. One is the allocation concealment was not very clear in these studies, and there's going to, of course, a lot of loss of data. So let's go through some examples of when you're trying to evaluate these types of biases, how you can actually go ahead and do so. So we're going to, this is now going to be interactive. I'll give you a scenario. You tell me, is this high, low, or unclear risk of bias? So let's first talk about sequence allocation. So determining who receives which treatment. So participants were randomized into two groups based on their medical record number. Would this be a high, low, or unclear risk of bias? Please write into the questions box. How would you assess this? I'll wait for a couple people to write something. Okay, we have a few answers. Okay, most people are writing unclear, a couple of highs and a couple of lows. Well, generally in terms of sequence allocation, you should never base it on anything that could be predictable, such as the date they arrived at the clinic, medical record numbers, birthdays, etc. Anytime you see that, so it's very low randomization, it would then, of course, going to give you a very high risk of bias. So if we were going to assess this study and we saw this is how they determined their allocation, we'd say this is a high risk of bias for sequence allocation. What about if participants were randomized into the two groups by flipping a coin? So heads, they go into group A, tails, they go into group B. Would this be a high or low risk of bias or unclear? In other words, the randomization. And everybody's saying low, definitely. This is purely random. We know they're not going to be biased in who goes into which. It's going to be a purely random chance if they're in either a group A or in group B. And then if the study you're evaluating said participants were randomized into two groups, how would you rate this? Everyone's rating unclear. Yes, we don't know how they're randomized. So in this case, it would be unclear. Now, anytime you rate any studies unclear, this is the great time. Contact the authors. Say in your study, in your paper, you did not emphasize how the allocation sequence was randomized or how it was being monitored. Can you please give me more information about the study's methodology? Maybe they just didn't write it in the paper. Maybe they use a nice central system and it was very, randomized, in which case it would be low risk of bias. But if this is all you see, you can't make that assessment. So anytime you see an unclear risk of bias, contact the authors. Now, in terms of allocation concealment, there's two aspects to this. One is concealment, which means nobody knows what treatment they are going to receive. Blinding means once they've been put into that group, will they know if they get it, yes or no? And now concealment is always possible. You can always ensure that before they start receiving the intervention, they won't know what they're receiving. But once they start receiving that intervention, then of course, this may be possible for them to determine, either them or the assessors, so the investigators of the study. So concealment should always be there. Blinding, you just have to hope. Of course, double-blind studies will be best, of course. So another aspect for allocation concealment, that's why there's two dimensions for allocation concealment. One is related to concealment, the other one's related to blinding. And that's going to be this next set of questions. So we have the treatment allocation was performed using a centralized telephone system. Okay, that was one scenario. Two, participants were allocated to one of two treatments using envelopes. And three, participants were allocated to treatment A if their birth date was an odd number and treatment B if their birth date was an even number. Now we're talking about masking, so blinding of the investigators. Which of these systems do you think is going to have the highest risk of bias? So Hala, if we can please launch poll number 1 for everyone.
Thank you, Dr. Jeffrey, and I think everyone now can see the poll on your screen.
So which scenario has a high risk of bias? And I'm saying in terms of concealment, so masking from the investigator's perspective, that they don't know which treatment the participant will receive. Is it the first one, treatment allocation using a central system? B, treatment allocation using envelopes? Or C, treatment allocation based on birthday? Which one has the highest risk of bias?
Thank you, everyone, for your participation. I will now close the poll, Dr. Jeffrey.
Thank you. Okay, we can see the most popular option with almost half was the last, treatment allocation based on birthday. That's of course correct. Remember, we're trying to mask the investigator that they don't know which treatment the actual participant's going to receive. If I were be able to determine that someone born on a even birthday received treatment A, then I automatically know the next patient that comes in, oh, even birthday, they're obviously going to get A. Odd birthday, they're obviously going to get treatment B. That's a very high risk of bias. I can see 35% of you said treatment allocation using a centralized system. Well, for using a centralized system that the investigator is not involved with, that would have very low risk of bias because the investigator would have no clue what type of treatment that the next participant is going to receive. And then only 20% of you chose treatment allocation using envelopes. Basically, that's just unclear. So yes, so treatment, so the first scenario that would be considered very low risk of bias. Anytime you see a centralized system determining allocation, that's always going to be best. Treatment allocation using envelopes is fine, but it should be emphasized they're opaque, sealed envelopes. And that way, when as an investigator, when I'm handing someone the envelope, I have no clue what treatment they're going to receive inside. And then 3, as we mentioned, anything based on something predictable. The number of patients that enrolled in the study, their medical record number, their birthday, anything is predictable means as an investigator, I am no longer masked if it was meant to be a double-blinded study. So this is another type of thing you need to try to ensure that's going to be robust and rigorous in the studies you are evaluating. So next we're going to looking at blinding of the participants and personnel. So participants and investigators were blind to the treatment allocation. The drug produced important side effects compared with the placebo. Raise your hand if you think this looks like a high risk of bias, that either the patient or the investigator will clearly know what intervention they're receiving. Okay. Only 7%. Okay, now up to about 10%, 15 now. Okay, so but not many of you. Most of you think, no, Jeff, this looks like low risk. Well, let's say I'm a participant in a study and I know I'm getting one of two drugs. I'm getting drug A or I'm going to get a placebo. I take it and all of a sudden I start having side effects which are related to drug A. Do you think I'm going to assume I'm receiving drug A? Of course. And if I know other people are having these side effects, yet I'm part of the study, but I'm not having any side effects, then it's very clear I have the placebo. And the same is true with the investigator. If the people are coming in for their follow-up appointments and they're complaining about the side effects, it's obvious they're receiving the intervention. So this would be a very high risk of bias. So any potential side effects of interventions should always be treated along with the actual intervention itself to ensure that there's not going to be any unblinding in the study. So this would be very high risk of bias. Other cases in terms of blinding, so low risk of bias would be using a double blinding model where the two drugs were matched in size, color, weight, and flavor. So regardless, the participant nor the investigator could have any clue which drug they're receiving. That's a low risk of bias. And then unclear would be if a study said patients were randomized to each intervention. Again, not enough information, contact the authors. Next is looking at blinding of outcome assessment. So in this kind of case, it was more like a measurement bias. So based on their medical chart number, patients were randomized to the treatment, even number, or placebo, odd number groups. Two independent clinicians rated each outcome. Or two, in this RCT, we use a double-blind procedure. Or three, both Alzheimer patients and clinicians were blind to the treatment allocation, and the tablet shared similar sensory features. Two experienced neurologists assessed the brain scans. The patient's treatments were revealed at the end of the study by opening a sealed envelope that detailed the randomization sequence. So of options 1, 2, and 3, which one do you think has the lowest risk of bias? Right in the questions box, 1, 2, or 3. And everybody's writing 3, and definitely 3 would be the lowest risk of bias. Again, anytime things are based on anything predictable, it's a high risk of bias. And when they're not giving enough information, which is option 2, that's going to be unclear, where you need to contact the author. And I'll just go through the other two dimensions quickly. One about incomplete outcome data related to attrition bias. So if they just said a total of 375 participants completed the study, well, out of how many? How is this really going to help us in terms of assessing any potential dropouts, attrition rates? Or a low risk of bias would be like, as illustrated in the flow chart, among the 463 enrolled participants, 461 randomized. 10 of those participants, which is 2%, did not complete the study. So therefore, the data of 451 participants were analyzed. Clear, descriptive, and only 2% attrition, we know very low risk of bias. If we see the attrition rate, they may not mention it, or if we calculate the attrition rate was 23%, that's going to be a very high risk of bias. Generally, any study, RCT at least, that has an attrition greater than 20% raises serious concerns, either A, about the way the study was designed, or B, about the actual intervention that was being used. So in another case, going to decrease the reliability of that data. And then lastly, for selective reporting outcome reporting, low risk of bias would be option 1. So in this RCT, testing the efficacy of a hypertensive drug, our primary and secondary outcomes were differences in systolic and diastolic blood pressures from baseline. And the reduction of the systolic blood pressure and diastolic blood pressure were 7 and 8 milligrams of mercury for the hypertensive drug group, P less than 0.05, as well as 2 and 3 milligrams of mercury for the placebo group, P is greater than 0.05. Why is that low? It's very descriptive, and you see all the information, both positive and negative, are being presented. High risk of bias would be like the second option for outcome reporting. So in this dietary study, outcomes of interest were weight loss, BMI, percentage body fat, and fat mass. Participants were significantly lost weight from 106 to 101 kilograms and reduced their BMI from this value to this value. Other measurements were not significant. What other measurements do they take? We have an idea, but there's not being shared. And so now we're left guessing how severe, or what was how was it trending to significance? That information is not available. So this is a high risk of bias. They're not sharing the information that they should be. See this, contact the authors. On the option 3, so in this RCT, we measured the efficacy of a new analgesic compared to morphine. The pain scores were similar between groups. The main side effects were comparable and included dizziness, nausea, and for both analgesics. So again, this is unclear because the data is simply not being shared. Anytime there's unclarity, please contact the authors. So yes, when you're doing a systematic review, you have to evaluate every one of your studies on all of these different dimensions to be able to assess any potential biases that could affect the data reliability, accuracy, or reproducibility. Now, in terms of quality of evidence, that's evaluating bias. We also have to evaluate the quality of the evidence, and there's a couple of ways to do so. I'll first share for observational studies, and then I'll share what's commonly used for RCTs. For observational studies, you often will see the Newcastle-Ottawa Quality Assessment Scale, and they do have separate criteria for both case-controlled studies and cohort studies. There's basically three key things that you want to look at: the selection of the cohorts or the cases, the comparability of the two groups, and the exposure and outcome measurements. So here's the Newcastle-Ottawa scale for the cohort studies. For selection, you're asking, is the cohort going to be representative? What was the selection of the control group? Does that look like it's appropriate? How do they determine their exposures? And was the outcome not present at the beginning, as it shouldn't be, right? You fix the exposures and evaluate your outcomes later on. The next dimensions on comparability. So what factors did the study control for between the two exposure groups to ensure that they are in fact proper controls for one another? And in terms of the outcome dimension, so how is the outcome being assessed? Is it long-term follow-up, and do you feel that the follow-up was adequate or not? For case-controlled studies, they have a separate assessment scale that you can use, the same basic dimensions for selection. How is the case being defined? How representative are those cases? How did they select the controls in those studies? And how do they define what the controls should be? The next one is comparability. So how do the factors compare for the study control for the differences between cases and the control groups? And finally, exposures. How were the exposures determined? Is it the same method for both the cases and the controls? And what about non-responsive rates? So I do encourage you, when you're going through, it doesn't matter if it's a observational study, an RCT, you always want to ensure that the study was conducted with strong technical rigor. If not, you're going to decrease the data reliability and accuracy, and therefore the representativeness they would have in your systematic review or meta-analysis. For RCTs, what the most common one is GRADE, which stands for Grading Recommendations, Assessment, Development, and Evaluation. And within GRADE, there's 6 key dimensions, and you can go to GRADE to get that information online. It's helping to identify potential risk of biases, heterogeneity across in terms of the results that are being presented, the indirectness of the evidence, so how well do they follow the population intervention comparison and outcome, imprecision related to the confidence intervals that are being presented, any potential publication biases, and other factors related to grading the quality of evidence in the systematic review. So with that, let's now go on to our second poll. Now in the second poll, how many assessors, we talked about assessing bias, assessing the quality of evidence. How many assessors should you be using to evaluate bias in your studies? So do you think one is enough? As long as they're objective, and especially if they're experienced, that should be fine. Or do you think you should have 2 of them, and then they're going to compare their 2 assessments? Option 3, you think you should have 3 assessors, and then you'll take the majority. If 2 say this, 1 say that, you go with the 2. Or do you think 2 is fine, but then you can have a 3rd one to resolve any conflicts between those 2? So Hala, let's go ahead and launch poll number 2 for everyone.
Yes, Dr. Jeffrey. So everyone should now see the poll on your screen. I will leave it for 1 minute, and then I will be sharing the results with you. Thank you.
Okay, so I can see the most popular option was the last one, that 2 is fine. but it's good to have a third to resolve any conflicts. And I would certainly agree that's going to be best. Some people, almost a third of you, said having 3, not necessary. And that is probably too much work. Sure, of course, more is going to be fine. However, it's really not necessary. Having 2 and then simply having a third to resolve those conflicts is going to be fine. Same way in terms of screening the studies, like we talked about in the first webinar. Same will be true with evaluating the actual biases in those studies as well. Thank you very much, Hala. So let's give an example of how a paper has described clearly and transparently the biases in their study. So this is one comparing statins for secondary prevention of patients with ischemic stroke or transient ischemic attack. Now in this paper, they first emphasized the assessment tool that was being used. As I mentioned, what people often use is the one from the Cochrane collaboration, and that's exactly the one that they used, as they mentioned here. If you use a different one, mention it. And they go on to say the following domains of bias were considered. So selection bias, performance bias, detection bias, and attrition bias, and selective reporting bias. So those are those different dimensions we already had gone through, as well as the role of the sponsor in the authorship of each study report. And then we clarified each one as being low, high, or unclear. It's exactly the same what we just went through together. Now, in terms of blinding, they said we consider the blinding of participants, personnel, and outcome assessments separately for objective outcomes and for mortality, or subjective outcomes. Of course, if you have subjective outcomes, being blinded is going to be really important. For objective outcomes, blinding of the assessors, of course, always fine, it's always good, but it's not going to be a necessity. But subjective outcomes will be even more important to ensure that the assessors are going to be blinded in this study. They also talked about incomplete data. So we evaluated the incomplete outcome data as having a low risk of bias when the numbers and reasons for dropouts were balanced. So the number of people that dropped out of each arm of the study were about the same. But if a lot more people dropped out of the interventional arm compared with the control arm, then that's going to be a high risk of bias, suggesting there's something problematic with that intervention. And they said that our assessment of methodological quality included published trial protocols when available. So as, for example, for RCTs, generally they're going to be registering the protocols before they're conducting. So in other words, what they're saying that they've done is they compared the methods in the published paper with that of the actual clinical trials registry to ensure that they did not deviate too much. Why is that an issue? Well, if you see a published paper that deviated very strongly from the original protocol that's in the trials registry, what that often suggests is what we call data dredging, that the results they hope to obtain, they didn't obtain. So therefore, they started to change the methodology to try to improve the positive or significant results in their study. And that probably suggests they originally didn't receive those significant results. And so that would be a risk of bias. Then the summary, they said the summary of the quality of evidence, we consolidated allocation concealment, blinding, etc. And a high risk of bias was when at least one criteria was a high risk of bias and a moderate risk was when the remaining cases. And finally, in terms of the assessors, this appraisal was conducted by pairs of independent reviewers with conflicts resolved by a third reviewer, which most of you chose as being the best way to evaluate bias in these systematic reviews. So it's not only important you know how to do it properly, but you have to report it properly in your papers as well. This is what is going to be expected when your papers are being evaluated by peer reviewers or editors of your target journal. Now, in terms of the rating the quality of the paper, so they use the GRADE framework, the one I had mentioned earlier, which is commonly used on the 6 different dimensions. They said that we revised and assessed each grade item, which of these 6 different dimensions, considering issues related to specifically to the network meta-analysis methodology. We'll talk the difference between paired meta-analyses and network meta-analyses a bit later. The presence of indirect comparisons, influence of each direct piece of the network meta-analysis evidence, and the role of consistency assumption of the validity of the estimates. So they made modifications and they're very transparent and they shared what modifications were being made and why they're being made. So generally speaking, from a reviewer's perspective, as long as you are transparent in describing how that information is being presented, the reviewers will be fine. So now let's go on to talk about, we talked about biases in the studies you're evaluating. Let's now talk about the biases in your study, the systematic review itself. You need to have strong technical rigor. So what type of biases can affect a systematic review? Well, one, it could be a selection bias, what studies you're going to be choosing. Two, information bias. And three, an analysis bias. Selection bias will be one of the most predominant ones, and that's the one we're going to be focusing on now. So selection bias means, as a reviewer, as a systematic reviewer, did you select all of the studies that are available related to your question of interest? So in other words, did you actually assess potential publication bias? Now, what a publication bias is means that if I have a positive study where my hypothesis is correct and I have great results, I'm probably going to want to publish that study. And from an editor's perspective, they will want to publish that study. But let's say my hypothesis was wrong. I'm trying to evaluate, does intervention X have the outcome Y? And we find, no, it does not, at least no better than the placebo or the control group. Will I feel interested in actually going through all that work of writing a paper and publishing just to say, no, it didn't work? Probably not. And even if I did do that, do you think a lot of journals would want to publish that research? Probably not. That's a publication bias. And so generally speaking, when you're trying to evaluate the literature, it's quite easy to find studies with positive results. It's much more challenging to find studies with negative results. And that's the whole point of searching the gray literature we talked about earlier. The gray literature helps you to try to evaluate those unpublished studies. Now the question is, how common are randomized controlled trials not published? Well, there's a nice study that evaluated this. It's called Timing and Completeness of Trial Results, posted at clinicaltrials.gov, which is the largest clinical trials registry, and published in journals. Now, what they did in this study is they randomly selected 600 completed trials from clinicaltrials.gov. And then they went on to try to determine what % of those trials actually got published in a journal. So let's go ahead, Hala, and launch poll number 3 for everyone. What % of these trials do you think they found published in journals?
Thank you everyone for your participation. So now the results are available on the screen.
So I can see the most popular option at 44% was that only 25% of the trials went on to get published. So it's quite pessimistic view in terms of publication bias. And then a quarter of you chose 50%, and then the remaining chose either 10%, and then 17% of you were quite optimistic, thinking that majority were in fact published. Thank you very much, Hala. So for the 26% of you that chose 50%, that was actually the number. So they found that 297, so about 50% of those trials. I've seen previous studies that also found about 50% of trials that are registered go on to get published. But let me emphasize that point again. Trials that are registered that go on to get published. A lot of people conduct RCTs without even registering them. So the ones that are registering their RCTs prospectively are probably the more reputable or more the researchers you can have more confidence in. So there's probably a lot more trials that are not getting published. We're just looking at the trials where the investigators performed it the right way, so prospective registration. But even amongst that cohort is still only about 50%. That means half of all completed trials go unpublished. And if you're only looking at the published literature, you're going to skew your results considerably. But they also found another very important observation. Because of these 297 trials that got published, they then compared the results from the trials registry from what was actually published in the journal. And what they found was this: that reporting was significantly more complete in the trials registry than in the published article for the flow of participants, for the efficacy of the results, for adverse events. Look at that difference, 73% versus 45% of papers actually presented adverse events, even though almost 3/4 presented adverse events in the trials registry. And for serious adverse events, almost all the trials in the trials registry reported these serious adverse events, but only 2/3 of the papers reported them. So that means even for the ones that get published, the information being shared and being disseminated can be quite different from the real evidence they obtained. Often what's being published, it has a more positive spin. They have a tendency to downplay adverse events, but of course, understanding the adverse events is essential in a systematic review or meta-analysis. So generally what I'm trying to emphasize is that just because the paper is published doesn't mean you don't have to check the trials registry. I do encourage you to do so. And that's what I mentioned in that previous example. That's exactly what they had done. They had gone back to review the trial registries to ensure the accuracy of the information in terms of methodological rigor, as well as the accuracy or the thoroughness of the reporting of the outcomes. So how can you tell, how can you present that you don't have any potential publication bias? Well, there's a couple of different ways. Probably the most common way is with a visual plot, such as a funnel plot, and then the other common way is a statistical analysis. Let's first look at the visual analysis, which is a funnel plot. Now for a funnel plot, let me explain what you're looking at. On the x-axis, you're looking at the risk ratio, which is going to be, of course, a log scale. And then on the y-axis, you're actually looking at the standard error, which is a measure of precision. But what's a little bit confusing about funnel plots, it's reversed. So in other words, 0 is at the top, and then the numbers get higher as you go down. What that means is that at the bottom of the scale, which you have a high standard error, means you have low precision. Those are usually the studies that have a high degree of variance, a high degree of variability, usually the smaller studies. As you go up the y-axis, so the actual standard error is getting smaller, which means the precision is getting higher, therefore you have less variance, are usually the more rigorous studies, the more robust studies, they're usually the larger studies. That's why they have less variance. So the idea is that those studies that have less amount of variance will cluster around the main effect, shown by this orange line here. But as you get to the studies that have greater degree of variance, you're going to see those studies scatter out. And they should scatter out equally to one side of the main effect or the other side of the effect, if they're going to be accurately published. So these may be the positive studies, these will be the negative studies, but if they're having that variance, it should be equal. So basically, if you don't have any publication bias, what you're going to see is a funnel, narrow at the top, wide at the bottom. Now, the other way you can assess this, and many actually do both a visual analysis as well as a statistical analysis, is an Eggers test. And the Eggers test is basically, if you do see a significant result, that means you have publication bias. So it's kind of the opposite. What you want to see is a non-significant result. If you have a non-significant result, that means your risk of publication bias is going to be very low. So you may want to do one or either or both to try to assess publication bias. As long as you see symmetry, you probably can feel quite confident. Well, let's look at this example. So here's all the studies. These are, by the way, I should emphasize, I'm sorry, these individual dots are the individual studies. So these are the individual risk ratios of these individual studies. And that's how you can assess there's not going to be any publication bias. But in this case here, do you think this symmetry, the distribution of these studies is very symmetrical around the central value? Raise your hand if you think, yes, Jeff, it looks very symmetrical. Very few people, only 10% of you are raising your hand. You're exactly correct. If you look at this, you're going to see this big hole right here. Now, what does that tell us? That means these lower quality studies, smaller studies, studies with higher variance that had negative results, you didn't find. And probability speak says you should have, because if there's a high degree of variance, there's going to be equal probability of good results and bad results, or positive and negative results. So when you see asymmetry, it suggests it could be, it's a risk of publication bias. Doesn't mean it is, it just means there is a risk of publication bias if you perform a funnel plot and you see a big gap, usually on to the right of the main effect that you're evaluating. Well, what about this case here? So in this case, again, we'll have these different studies that have been plotted with the 95%, these dotted lines at the 95% limit lines, confidence interval lines. So in this case, do you think we have a symmetrical distribution of these studies? Raise your hand. So it's going up a little bit higher. Before it was 10%, now we're about 18%, but a lot of you are still saying, no, Jeff, actually, I can't really assess symmetry. And that's the good point. One of the limitations of a funnel plot, if you have fewer than 10 studies, it's really not practical. You cannot really assess if there's going to be symmetry or not. For example, if let's say you had a lot more studies and you started adding a lot of studies here and here, yes, you're going to end up with a big gaping hole, suggesting yes, publication bias. But if you only have 4 or 5 studies, it's not possible. So someone had asked me earlier, how do you ensure that how many studies do you need to have a really technically rigorous or robust systematic review or meta-analysis? And I said greater than 10. And the reason I gave that value is that if you have less than 10 studies, it's difficult to really evaluate potential publication bias in your study. So that's always a limitation. Doesn't mean you can't do it, but you have to emphasize in your limitations in the discussion that due to the few number of studies included into this review, we are unable to assess publication bias in our systematic review, and therefore additional systematic reviews should be conducted once more RCTs are available. That's a limitation you should transparently describe. So let's look at a real example. These are examples that I made for these workshops. Let's look at a real example. This is looking at the benefits and adverse effects of ACE inhibitors in patients with heart failure with reduced ejection fraction. Now here's the funnel plot. This was a supplementary figure. So if you saw this funnel plot, do you think that this study has potential publication bias in the review? Right? Yes or no in the questions box. If you were to assess this as a reviewer, and yes, everyone's writing yes. I think everyone could see this big, huge hole in the funnel. Again, usually to the side, suggesting negative studies with low variance were not found. And probability says there should be at least a few there. So now these authors then need to really clarify that there is a potential publication bias in their study. And that's what they go on to do. They said it is thus possible that some RCTs published in other databases or unpublished RCTs may not have been included. Again, it doesn't guarantee publication bias. It just means there is a risk of publication bias. In positive data are more readily published, implying that the unpublished data are likely to be unfavorable. So is publication bias problematic in systematic reviews and meta-analyses? Unfortunately, it is. Here's a recent paper published a couple of years ago where they wanted to evaluate the evaluation of publication bias in systematic reviews in orthopedic literature. and they evaluated 694 published systematic reviews in PubMed published between 2013 and 2016. And what we can show, what I have highlighted in the red box, 80% of those studies did not evaluate publication bias, and therefore could really impact the reliability or the relevance of the results of those studies. So now that you do know that publication bias is something you should evaluate, please, when you conduct your systematic review, do so. Now, that said, on a last note before we get to our break, I do understand the challenges, not say I, but we as publishers, as reviewers, we do understand the challenges with publication bias. Simply, published data is easy to find. Positive studies are easy to find. It is a challenge to find those unpublished studies. And even when you do find them, you have to contact the authors and get that information from the authors. And those authors, perhaps worried about the reputation, may not want to share that negative results with you because they think it may reflect poorly on them. So even if you find them, you still may not be able to get that information necessary. So in other words, reviewers and editors do understand the issues, that we don't expect you to be perfect. It is not possible in a real world. But what we do expect is transparency. If you had any challenges in finding unpublished literature, negative data or negative results, or many authors refuse to share, this is all information that could be easily described in the discussion section. What that shows reviewers in terms of establishing your credibility, you knew exactly what you should have done. You did your best to do it, but of course, you have limitations on what you're able to be able to retrieve, and we'd understand that. So all we ask is that when you are describing and conducting your analyses, always be as transparent as possible. So with that, that's now going to bring us to our break. As before, the first 10 minutes will be for you. When we come back, we'll go ahead and discuss other aspects related to biases and systematic reviews, and then we'll be talking, comparing, and contrasting qualitative and quantitative syntheses in your studies. So with that, thank you so much, everyone, for your fantastic participation thus far. Have a great break ahead. Think of some questions and be sure to write them into the questions box. And when we come back, we'll then go through our Q&A sessions. Thank you so much, everyone. Okay, so welcome back from the break, everyone. I can see a lot of great questions came in during the break, which is always fantastic. So now Hala will go ahead and read through the questions that we've had and the time we have available. Any additional questions we'll be sure to cover at the end of the workshop today. So Hala, can we please read out some of the questions from the attendees?
Yes, Dr. Jeffrey, and thank you everyone for your participation. The first question we have here, please clarify again attrition bias.
Great question. So attrition bias basically means dropout. So what happens is when you're conducting an RCT, let's say the intervention that you're using causes some really serious side effects whereby people just don't want to continue in that study anymore. So what do? They drop out. Now, the question is, there's two important aspects related to attrition bias. One is, how do those investigators handle that missing data? There's a variety of ways to handle missing data depending on the type of missing data that it is. But the second is the number of people drop out. In general, when more than 20% of people drop out, especially if it's heavily weighted in the interventional arm, so the ones receiving the drug, that usually suggests there's some major concerns with that drug, or at least how it's being administered. And therefore, it also suggests it's probably not going to be will not be useful in the clinic. So the attrition bias is really related to those types of ideas. Good question. Thank you for letting me clarify.
Thank you, Dr. Jeff. And the following question we have here, some of the reviews articles are mainly descriptive in nature without date, as a certain drug is still new. Are they considered not accurate?
So if it, I assume you're referring to systematic reviews, not literature reviews. So if you're talking about systematic reviews, that if they're not indicating date, I'm not sure if you mean date in terms of when they searched or date of when those actually studies were actually published. Both of them should always be presented. Because, for example, let's say that I don't emphasize that I conducted my the analysis. Maybe I did the initial selection 3 years ago. I'm busy. I don't have a lot of time to do my systematic review, so I'm just letting it to drag on. Well, that means if I haven't updated my search in the last 3 years, is my systematic review now still relevant for the field? Maybe not. There could be some other additional studies that have been published in the last 3 years that would be really relevant for my systematic review. And so if I'm not providing you as a reviewer, as a reader, the dates of when I conducted my search, you cannot make that assessment in terms of the rigor of my systematic review. And that's why it's so important from a reviewer's perspective, a peer reviewer's perspective, that those people conducting these systematic reviews do indicate the dates of when the searches were done. And so I encourage for you, when you are performing your systematic review, always indicate the date. And I showed you an example earlier that they also did an update. They started, and then maybe 1 or 2 years later, they did an updated search just to identify any other potential studies as well. If you do that, please ensure you emphasize that in your methodology.
Thank you, Dr. Jeff. And the following question we have here, how can I get the unpublished data for non-clinical field? For example, pharmaceutical formulations.
So I think getting unpublished data from clinical trials is not easy, but it's much easier than other fields. And that's not just outside of medicine. Observational studies, cohorts, case-controlled studies, they're clinical as well, but generally they're not going to be registering those studies, in which case there's no database for you to find them. So the best way to find any of those non-RCT types of research, clinical or non-clinical, would be to use those types of databases that I showed you earlier. So it's what they evaluate the gray literature. So there's one based on the EU, Google Scholar can do the same thing. What these types of databases do is they look at not only published articles, but they look for conference abstracts, dissertations, trade magazines, policy documents, any other type of information that's describing that drugs and is related to your question. And so if you do a search on that drug of interest and you see some reports, white papers, conference presentations about that drug that you can't find in the published literature, that would be the best way to identify them.
Thank you, Dr. Jeffrey. And another question here. Can I use the quality assessment skills during research conduction and peer review?
Definitely. Great question. One of the key things I mentioned in the very beginning about one of the really, I think, valuable attributes of being a systematic reviewer, doing your meta-analyses, it improves your clinical research skills. By you learning how to evaluate other people's studies, to evaluate in terms of the quality of evidence, biases, etc., that makes you more aware that when you're designing your study, you're aware of those biases, and you're ensuring you're going to overcome those types of limitations, and you're also going to be more careful in terms of how you conduct your research. So definitely, I certainly encourage you to use those types of the grading scales we talked about, those outcome assessments, bias assessments, to really ensure that your research is conducted as reputably as possible. Related to that as well, what I'll put into the chat box in terms of if you really want a great resource to help navigate what information you should be including in your research papers, regardless of the study design you use, is called the equatornetwork.org. And I'm not sure if it's as a equator, I'm not sure if there's a hyphen or not, so I'll put both links in there for you. So, what these do is they give you checklists related to a variety of different study designs, RCTs, diagnostic studies, animal studies, and they're simply checklists of information you should be including. Prisma is in there as well, the Prisma checklist for systematic reviews. And these can be quite useful in addition to those other types of assessment tools. I think all of them together really helped you to understand the international standards that are expected of researchers to conducting their types of clinical trials that you should be aware of when you're conducting your own. Great question.
Thank you, Dr. Jeff. And another question here. Green publication means unpublished data, or also what are indexed in Google Scholar?
So that's a great question. And I'm going to slightly rephrase the question. What is Google Scholar? Is Google Scholar a published database or not? And generally it's a mix. It's everything. So other databases like PubMed, Scopus, Web of Science, these are journal specific databases. Journals apply to be included in that database, and they're very selective. So in those databases, you're only looking at peer-reviewed journals. Google Scholar, no one has to apply for. Google Scholar, they send out their web bots online, try to find anything that looks somewhat academic, and then they're going to index it. So that includes published articles in journals, includes books, trade magazines, conference proceedings, policy documents, dissertations, slide decks that people have shared online, anything that looks academic. So yeah, Google Scholar, don't confuse with things like Scopus or Web of Science. It's very, very different. Google Scholar will find both published and unpublished research. That's why I recommend to use Google Scholar in trying to identify those unpublished findings.
Thank you, Dr. Jeffrey. And I guess we have time for one more question.
Sure.
If I am interested in a certain topic and I searched the database that were mentioned before, and I already find a group working on the same topic, so is it allowed for me to ask them for my participation?
So I think I'm going to give a scenario that I think is what the attendee is asking. Let's say you're searching on Prospero, you're trying to design your systematic review, and as we discussed, go to Prospero database, try to see if anybody else is doing one, and you see that there is already a registered systematic review related to the topic that you wanted to conduct. But maybe you see it just started. It's still in the very early stages. Can you reach out to them and ask, do they want to collaborate? Of course you can. But please be aware, if they've already started, that means they probably have already assembled their team, which means they probably realized they don't need other people. My suggestion, if you want to increase your chance of being included as part of that research collaboration, is to try to also emphasize what unique features can you bring to their group? What can you bring that you think that the other members of the group may not have? What are your strengths? And by trying to leverage your strengths when you're communicating them by email in a friendly, professional way, you'll probably increase the likelihood that they may wish to include you as part of the research collaboration. But again, because they've already established their group, they probably would only include you if they feel you're bringing something that they don't already have. But does it hurt to ask? Of course not. Just make sure you ask in the right way. Great question.
Thank you, Dr. Jeffrey, and thank you everyone for your participation and your questions for today. And we will be having another Q&A at the end of the session.
Fantastic. Thanks so much, Hala. And thank you so much for so many fantastic questions coming in from the attendees. It's really important for me to see that everyone feels this topic is something important, something you want to learn more about and improve your skills on. So I'm really happy to see that. So now moving back to the workshop, we talked about already in terms of biases and the studies. We talked about one of the common biases in systematic reviews, probably the most important one, selection biases in terms of selecting studies. But there's also additional biases you should be aware of as well. Second one we want to talk about is information bias. Now this is related to the people conducting that systematic review. It gets back to the last question in the Q&A session. What do you bring to that group that will ensure that that systematic review is going to be conducted properly and thoroughly? So experience and training could potentially affect how that systematic review is going to be conducted. In terms of the assessment of quality and bias, if someone has not published a lot of clinical papers and then you're asking that person to assess quality and bias in other clinical papers, do they really know what to look for? Yes, those tools help, they guide them, but they don't tell them what to look for. What are the common problems or what are the common strengths that they should be trying to be mindful of? And of course, also in terms of extracting data from selected studies, especially if you're not using a standardized data extraction form like the one from Cochrane Collaboration or from Covidence, and also in terms of completeness, again, especially if you're not using a standardized data extraction form. Now, interestingly, it has been shown that actually experience does not really seem to have a big effect on information bias. What helps to kind of really resolve this issue is just always having at least two evaluate and extract that data or to evaluate that data or evaluate those biases. And when you have two independent people doing the same thing, that helps to minimize any potential information bias that the systematic review may have. Now that in mind, people have also thought that maybe it's important to blind the reviewers, that they don't know who conducted those studies. In other words, maybe one group of people are selecting the studies and then they're blinding, they're taking away the names and the institution or the journals of where those papers were published with. They don't know if it's published or unpublished studies. And they're just simply giving that data to the extractors and say, okay, extract this data, analyze this data, evaluate these biases. And the reason for that, or the concern that people have, is whether or not the RCTs, or randomized controlled trials, or observational studies, any kind of studies, from a reputable author or from prestigious university or institution, does that necessarily mean that they're more trustworthy? Of course not. However, if someone sees, oh, here's an RCT from Oxford, well, they're probably going to have this first impression, this is probably a really good study. And they may not be as careful in evaluating it. But then the second RCT, which may come from an unknown institution in Vietnam, you may be a lot more skeptical and be a lot more critical in evaluating that study. So when you are evaluating studies, do not let the names or the institutions influence how you're going to assess it. Similarly, in terms of names and institutions, but also the journal of where it's published in. Just because a paper is published in the Lancet, does that mean it's much better quality than a RCT published elsewhere? Maybe, maybe not. It could just be that that RCT in the Lancet is much more relevant for the field right now. It has topical interest. So for example, you see a lot of RCTs being published related to COVID-19 that probably generally would never be get published in the Lancet. It's getting published in these top journals because of the topical interest right now. So don't always let the name of the journal influence how you're going to evaluate the studies either. And the same is true in terms of unpublished versus published. Just because it's unpublished doesn't mean it's worse. There's a variety of reasons why a study could be unpublished. It may be a great study, but let's say the lead investigator, had left the institution, or they decided to leave research, or they retired. And then there's simply nobody that was left to take over. And so they had to terminate the trial, they terminate the study. It doesn't mean it's a bad study. It just means that the person that should have published it didn't. So again, don't always assume an unpublished study is a bad study. Try to go into when you're evaluating these studies as objectively and as fairly as possible. Published, unpublished, journal name, author name, or institutional name should not cloud how you evaluate that information. And then the last bias is an analysis bias. We're going to go into a lot more detail. This will be the majority of the last section of today's webinar. But analysis bias means, should you actually be conducting a meta-analysis, or should you just do a systematic review? Or if you are doing a meta-analysis, how should you be evaluating that data based on heterogeneity? Now, we did have a question coming before in the first webinar about how do you handle heterogeneity when you're conducting a systematic review or meta-analysis. So if you have decided you're going to conduct a meta-analysis, then you have to assess the heterogeneity in that study. Does it look reasonable to pull that data together? If it seems there's going to be very little heterogeneity across all those studies, then maybe a fixed effect model will be appropriate. However, if it's going to have a lot of heterogeneity, you should be using random effects. And generally what you'll see, that if you do a both, and many people do a both fixed and random effects, if you do both and you see the output is about the same, that usually suggests that there was very little heterogeneity in that study. However, if you conduct both analyses, both the random effects and the fixed effect, and you see really different effects, really different results, that's usually suggestive that there is heterogeneity in your study, and the random effects model is probably more appropriate to represent that data. We're going to talk a lot more about systematic reviews, meta-analyses, fixed effects, random effects models, and how to present this information in your systematic review shortly. But before we do that, let's go through our next activity about publication bias. Now, I'm sorry, we already did the publication bias one. I'm sorry. Let me move on now. Now go on to about analyzing the data, the qualitative and quantitative syntheses. So in this case, now we talked about heterogeneity. Now, heterogeneity is not only relevant for meta-analyses, determining what type of model you should be using to conduct the analysis, but also to decide whether or not you should conduct a meta-analysis at all. If not, just do a qualitative synthesis. That's perfectly appropriate. So systematic reviews are easier because it is just a qualitative synthesis. There's no statistics involved. But because of the objectivity of the meta-analysis, they're often thought to be stronger and have a higher clinical relevance. So if you can conduct a meta-analysis, that's usually beneficial for you as well as for the field. Now, if you have a very homogeneous population in terms of all the different population of the studies that you're looking at, that the meta-analysis was likely going to be more preferred and give you a more precise estimate of the effect. Problem is, that's not always going to be the case. Sometimes when you look at the populations, you look at the different studies, you're going to see so much heterogeneity that maybe it doesn't really make sense to do a meta-analysis at all, in which case you would just do the qualitative synthesis instead. So I've mentioned these ideas of heterogeneity several times now. When I'm talking about heterogeneity, what type of features, clinical features, do you think affect the heterogeneity across these different studies? What kind of things do you think could cause heterogeneity across clinical research? There's a number, there's no right or wrong answer. There's lots of possibilities. Can someone please write some of your ideas in the questions box? You can see by ethnicity, difference in population characteristics, demographics, age groups, different methodologies, sample sizes, selection criteria, study designs. Exactly. There's a variety of different things that can actually influence the heterogeneity of a study. Often when you're talking about heterogeneity, especially related to meta-analyses or systematic reviews, they often talk about clinical heterogeneity and statistical heterogeneity. So first, let me introduce clinical heterogeneity, and that's really a lot of the information that people had highlighted in the questions box. So thank you for writing into the questions box. And it could be related to the different types of patients that are being looked at. It could be different interventions, but maybe for the same condition or same outcomes, or maybe same intervention, different outcomes, or it's the same intervention, same outcomes, but different routes of administration. There's a lot of things that can cause this clinical heterogeneity, which will cause a lot of differences and variances across those different studies. Now, if it is too heterogeneous and simply does not make sense to pool these papers together, then you should do a systematic review. But if you feel the heterogeneity that you see, this clinical heterogeneity, is not really that severe and really shouldn't impact the meta-analysis, then doing a meta-analysis will be fine. Once you've decided to do a meta-analysis, the next question is, will this heterogeneity affect how you're going to be evaluating that data? If you think that it is very homogeneous populations, same population, same intervention, same route of administration, same follow-up time, same outcomes, then yes, maybe you doing a fixed effect model will be appropriate. But if you see there's a lot of differences in how those studies are being conducted, then maybe doing a random effects model will be more appropriate. So clinical heterogeneity helps you to define, should you even do a meta-analysis to begin with? And if you do a meta-analysis, what type of model should you be using? But there's also statistical heterogeneity, and this is going to be a statistical test, the Cochrane Q test, the IQ, the I-squared statistic, and then there's ways you can help to try to evaluate, understand that heterogeneity with meta-regression, subgroup analyses, and sensitivity analyses. So this is what we're going to be talking about in the remainder of the webinar. So first, let's talk a little bit more about systematic reviews. So systematic reviews, often what you hear people talking is you can't compare apples and oranges. Yes, they're both fruits, but it doesn't make sense to group them together. They are different types of fruits. It doesn't mean you can't talk about them together. You can still talk about them together as fruits, but you need to keep their evaluations a little bit more distinct from one another. This is more what a systematic review is. It's just a qualitative synthesis of that data. And every systematic review or meta-analysis always has a qualitative synthesis. This is always required. It's whether or not you do the meta-analysis on top of this is what makes it a meta-analysis. So what is the purpose of a qualitative synthesis? Well, it's really to improve our understanding of the intervention's efficacy, or if you're looking at prognosis or diagnostic aspects, whatever really is the main outcomes that you want to understand about that factor exposure of interest. And just to help to improve our understanding, it's also for you as the reviewer of those studies to tell us about your confidence. Do you think, and when I talk about confidence and data integrity, I'm always thinking about data reliability, data accuracy, and data reproducibility. How confident are you in that data? And then lastly, for whom do you think this is going to be relevant for and under what circumstances? This is the general guidelines of when you're thinking about writing the qualitative synthesis. But in addition to this as well, and this is what we often see is missing, is to describe patterns. Just because you're not doing a quantitative synthesis doesn't mean you cannot see patterns across those studies. When you're looking at all of these studies, try to identify patterns across those studies and just try to describe those patterns. And often those patterns can be really important. They can really maybe give some insights of efficacy of a certain type of population, certain comorbidities, disease stage, severity, etc. And those are usually great ways to establish new hypotheses going forward for the field. Now, there's a great book. People have asked me about some websites or other ways to get more information. I introduced the Cochrane collaboration as one. Another really nice book from the Institute of Medicine in the United States, Standards for Systematic Reviews, again, freely available online. And they have some nice criteria, what they consider the standards for writing a good qualitative synthesis in your paper. One, as we mentioned, is to always to describe the clinical and methodological characteristics of all the included studies. Second, you should emphasize the strengths of the studies as well as the limitations of the studies. Third is to talk about any potential biases that you were able to find in the studies and the effect that has on the results. Fourth is to describe the relationships between those characteristics and those individual studies and across the studies, what I just emphasized on the bottom of the previous slide. And then finally, about the relevance of those studies, for whom and under what circumstances. So these are generally considered the 5 key criteria that you need to include in any good, well-written qualitative synthesis. Now, it's about the patterns or relationships that I think sometimes people misunderstand what that really means. So let me show you an example of not the entire qualitative synthesis, but simply where they discuss the patterns or relationships that they observed. So here's a paper published in BMC Pediatrics. So congenital heart disease diagnosed with echocardiogram in newborns with asymptomatic cardiac murmurs. And this, of course, just a systematic review, not the meta-analysis. So they say this was a systematic review, by the way, of 12 observational studies, not RCTs, but observational studies. And in that, there's a total across those 12 observational studies, there's 1,928 asymptomatic newborns that they evaluated. They had cardiac murmurs. And they said 719 were diagnosed with congenital heart disease. And then we, the reviewers of the study, the systematic reviewers, classified the congenital heart disease into 4 categories according to the anatomical region that produced the murmur: shunt lesions, right side heart lesions, left side heart lesions, or connection lesions. And they have the table for that. And then here's their evaluation, the patterns that they noticed, the relationships they noticed across these 12 different studies. They said amongst all of those newborns, across all of those 12 studies that had congenital heart disease, 56% of them had shunt lesions, and that the most common congenital heart disease was ventricular septal defects. So again, this was not from any individual study. This is their evaluation, looking at all 12, what were the common patterns and relationships that they've seen? And then they describe those. This is the qualitative synthesis. It's not no statistics. There's just numbers. It's not a statistical evaluation in terms of p-values or confidence intervals, but rather simply saying, here's what we see to be the most frequently occurring X, or the most frequently occurring Y, or most commonly shared characteristic, Z. These types of patterns across those studies can be quite useful. So when you're writing a qualitative synthesis, it's not simply summarizing the individual studies, but trying to understand and see potential relationships across them as well. And then the last thing we're going to talk about, because I think for a lot of people, it's a lot more difficult to really understand how to perform them properly. And again, I'm not going to go into the statistics behind it, but rather the principles behind it. And that is meta-analyses. So these are the quantitative syntheses. So you have all apples. You have all apples. Therefore, it makes sense to pull them together and to reevaluate all that data as one in terms of statistical reevaluation. Now, when you're performing your meta-analyses, there's some key points to think about. First, importantly, is what is the direction of the effect that you're in terms of the interventional's efficacy? Is it preventative, harmful, etc.? If you're looking at exposure, for example. Second, what is the size of the effect that you've seen? Third, is the effect consistent across the studies or not? If not, why? Is it in terms of the problems of potential biases in some of those studies? That's why the overall effect you see is not seen in some of those other studies. And then 4, what is the strengths of evidence of the effects? Not just biases, but the study design, the technical rigor, etc. So all of this information needs to be communicated when you're talking about the meta-analysis. The meta-analysis, because of this statistical reevaluation, it is a lot more work, because keep in mind, again, when you're doing a meta-analysis, you're still doing the qualitative synthesis. But in addition to the qualitative synthesis, you're doing the quantitative synthesis as well. And that's what I keep saying, it requires more work. So when does it make sense to actually do a meta-analysis to combine that data together? Well, first of all, you realize all the studies, and sometimes you may not know if you can combine it until you've already selected the studies. So once you've done your selection procedure, you don't start off knowing if you can do a meta-analysis or not. So you start off saying, I may do a meta-analysis. I'll definitely will do the systematic review. I may do a meta-analysis. Let me see the studies I finally have at the end. So you do your selection, you do your screening, and then once you have the screening, and now you've identified these are the RCTs I will include in my study. Can you do a meta-analysis on them, yes or no? If no, systematic review. If yes, meta-analysis. Sometimes what you'll see is a systematic review. The paper will be maybe 15 studies is the systematic review, 8 studies is the meta-analysis. Why? Because it only made sense to combine 8 of the studies together. The other ones were too different. So again, you need to be flexible and be adaptable based on the evidence you have that you've been able to retrieve from the published, unpublished literature. So if you see that the studies are all evaluating a common effect, and if you see they're all addressing the very basic same clinical questions, so in other words, apples and apples, then yes, it may make sense to pool the information together and do a meta-analysis. Keep in mind, however, not every study is going to be the same. There's going to be differences because they're done by different people. They're done in different populations. They're done at different times. There are going to be differences. So don't think that it's going to be no difference or difference. There are always differences. But this is where the subjective evaluation comes in. You need to make the subjective evaluation. Do I think that these differences are minimal or are they quite severe? Severe, systematic review. Minimal, then I can do a meta-analysis. So this is really based on what you believe is going to be appropriate. There's really no measure to try to make this definition. Now, in terms of types of meta-analyses, what the most standard one is a paired meta-analysis. So you have one intervention compared with a control, usually, for example, placebo or active comparator, but you're only looking at two arms in those studies. We can also do a network meta-analysis, which is a lot more complicated, especially statistically, where you're going to look at multiple but similar interventions for the same condition. Let me show you an example of what I mean by a network meta-analysis. So here's a paper published recently in The Lancet, looking at comparative efficacy and acceptability of 21 antidepressant drugs for acute treatment of adults with major depressive disorder. So this is looking at 21 antidepressants, not just one versus a control, but 21. And so it's a lot more complicated procedure to try to bring all this information together. And the way you often see it presented is in a map like this. So here's the network meta-analysis, whereas they describe here that what they have are all the different drugs with placebo. So they have all the 21 antidepressants that they evaluated around the edges. And what they're saying is that what the lines mean are the pairwise, the pair treatments in those individual studies. So this study compared this drug with this drug. This one compared this drug with this drug, this drug with this drug. So these are paired by paired, and they grouped them all together. So that's what the lines show. In terms of the width of the lines, is going to show the number of trials comparing those treatments. So those with one very thin lines, maybe one trial, one study. Those thicker lines, this means there's a lot more studies that were included. And the size of these circles tell you about the sample size. So in terms of the number of participants enrolled. So of course, placebo would have the most because everyone's comparing with placebo, but you can see then some of these others, the more popular antidepressants, are going to be much larger sample sizes than the others. So this is often how a network analysis is going to be presented to try to look at those interactions. And now when you do this, and then they're going to do the meta-analysis, they present the forest plot. It's not really listing all of the studies and then the overall effect at the bottom, but rather it's the overall effect individually, in this case, for each of the 21 different antidepressants. So here's the overall efficacy of all 21 antidepressants, and you can see for all 21, it does in fact favor the active drug. So it's presented slightly different than the pairwise meta-analysis, but the basic principles are still the same. So now the question is, I've talked about these fixed effects and random effects model before several times already. This is how you want to try to summarize the effects that you see across all those different studies. So how do you choose which one you should do? Statistically, these are different. So fixed effects means that you believe that there is one common effect across all of the different studies, and any variability that you observe in those studies is due to within study variance only. It's not due to between study variance. It's only within study variability. Now, one of the benefits, one of the reasons people like fixed effect models, they generally give you narrow confidence intervals, which makes the results look more robust. However, they're not really that common. Why? Well, again, this is what this means, graphically speaking. So if that means that for what the intervention you're looking at, there is one true effect, which will be true for everyone, regardless of who they are, where they live, age, etc. They're going to be true for everyone. That's the true effect. But what you see in these different studies is not because the effect is different across the studies, but rather the within variance within those studies will be different. That could be in terms of inclusion, exclusion criteria, methodological rigor, etc. So, but if all the studies were conducted properly, then you would see the same effect, which is really not that realistic. What's more realistic is that depending who conducts the study, where the study is conducted, what the patient populations being sampled from, etc., would yield a different effect for that drug. Not every study is going to be the same. And that's the point of random effects model. Random effects model says that there will be different effects, and that's fine. And that the variance that we see is going to be a within study variance, but also between study variance as well. But because of this increased variance, generally they will have broader confidence intervals, and that's why some people tend to shy away from the random effects model, because they like to have these narrow confidence intervals in their presentations. But it's probably more practical, more realistic for most meta-analyses. So graphically, it means something like this, that here's the overall mean of the true effects, but all of these are true effects, just for different studies, for different populations. But each one is a true effect. But of course, there will be kind of within variance as well, and that within variance is going to give you the observed effect. So you need to try to determine whether or not you should be using a fixed effect or random effects model. So when should you then? Well, let's look at our final poll of the webinar. So when should you use fixed versus random effects? A, should you always use a fixed effect because it gives you narrower confidence intervals? Should you always use a random effects because it's going to be more conservative? C, based on the calculated statistical heterogeneity that you obtain? D, use both and then compare the effects afterwards? Or E, consult with a statistician, they know best. So Hala, can we please launch poll number 5 for everyone?
Yes, everyone should now see the poll on your screen. I will leave it for 1 minute and I will be sharing the results with you. Good luck.
Okay, Hala, let's go ahead and share the results with everyone. So the most popular option was based on the calculated statistical heterogeneity, followed by consult with a statistician, they know best. And then the third place, use both and compare the effects. I would, of course, definitely agree with the fifth option. When you're doing any type of statistical analyses, consulting with a statistician will often save you a lot of headaches. Now, in terms of the calculated statistical heterogeneity, that is something that many people do. However, it's something that the Cochrane collaboration recommends to avoid doing. So based on this is what, a lot of people do have confusion which one to use. What the Cochrane handbooks recommends, if you go to the Cochrane handbook, this section, what they recommend is you do conduct both. And the results are very similar between the both. That usually suggests there's very little heterogeneity in your study. If the results are very different, that does suggest that there is heterogeneity. And the A, you need to report the random effects results. You can still report the other one, but you definitely need to report the random effects model. And you should try to explore the heterogeneity going forward. And they do specify that the choice between a fixed effect and random effects meta-analysis should never be made on the statistical test for heterogeneity. Now that brings us to our last topic of the webinar, which is statistical heterogeneity. And this is basically using a Cochrane Q test, I-squared statistic, basically to try to understand what type of, that the differences that you see is not due to random chance, that there is real heterogeneity in that studies. Now, there's a couple of ways you can assess heterogeneity. One is visual. So you can look and see whether or not the dotted line with your true effect, does it cross the line of all of the different confidence intervals? If yes, then probably suggests that you have low degree of heterogeneity. If the answer is no, then that means you probably can see this one and this one does not cross the dotted line. That usually suggests that you probably do have heterogeneity. You can also do the Cochrane's Q test, and if the p-value is greater than 0.05, it suggests that maybe homogeneous. If it's less than 0.05, it suggests it is heterogeneous. And then the last one you often see is the I-squared statistic. And what this evaluates, what's nice, it gives you kind of an idea to give how much heterogeneity you have. And these are really rough guidelines. I've seen different recommendations of what the percentage should be before you say it's moderate or high. But on average, if you have an I-squared statistic of maybe 0 to 30 or 0 to 40, that means you have very mild heterogeneity, and most of the variance that you see is probably within study variability. If you see 30 or 40 to 50 or 60, that's moderate, so still not too bad. And if you see maybe greater than 50% and definitely greater than 75%, that means you have very strong heterogeneity across your different studies. And what should you do if you have heterogeneity? You should explore it. And you can explore it with meta-regression analyses, with subgroup analyses, or sensitivity analyses. So with that, let's now move on to go to our last activity of the webinar, and this is activity 4. This is found on page 11 of your participant guide. So let's say you decide to evaluate the efficacy and safety of sorafenib compared with TACE in treating hepatocellular carcinoma based on previous studies. After selecting 11 potential studies, you notice differences in how TACE was performed. 6 of them used conventional TACE with Lipidol, while 5 studies used the drug-eluting beads TACE. And further, you also notice differences in sorafenib treatment across the studies as well. Which of the following would be the best way to evaluate these studies in your analysis? Would you only conduct a systematic review, so qualitative analysis? Being they're all looking at similar treatments with similar outcomes, it's fine to pull all the data together and conduct a meta-analysis with a fixed effects model. Or C, evaluate heterogeneity with a Q statistic or I-squared statistic. And if heterogeneity is high, then use random effects model to conduct your meta-analysis. So Hala, can we now launch the final poll for everybody, poll number 6? Which of these 3 options would you do? Okay, Hala, let's go ahead and share the results with everyone. You can see the most popular option amongst the attendees is the final one. Conduct a meta-analysis based on your test of statistical heterogeneity. And if it's high, then you'd want to do a random effects model. So thank you very much, Hala. So if someone came to me and asked for my advice, I would actually agree with the second most popular option, just do a systematic review. It looks like the way these studies were conducted were too different from one another, and therefore a qualitative synthesis, which can always be done, is probably more appropriate. Now, another option is maybe you want to do a meta-analysis on those that use conventional TACE, which was 6 studies, and those that use these drug-eluting beads TACE, which is 5 studies. But also keep in mind, there's also differences within the sorafenib treatment as well. So again, if there's going to be differences with how the sorafenib was being administered to the patients, again, that could cause heterogeneity that maybe does not make it really useful or informative to conduct a meta-analysis. So probably doing a systematic review is going to be most appropriate in this case. In this case, you would definitely not want to choose B, and I see that was the least popular option. Fixed effects model means when you have very homogeneous studies. In this case, you definitely don't have homogeneous studies. The administrations are quite different. And C, again, this is a common mistake, and at least, although it's still frequently done in the literature, at least when you look at the standardized standards for doing systematic reviews, the general recommendations, you should not base your choice of a fixed effect or random effects model on statistical heterogeneity. It's based on whether or not you think that the results within the studies are homogeneous enough for you to pool them together. Again, the safer way is just to do both. Compare the results obtained from both. If they're similar, that means there's low heterogeneity. If you see that they're very different, then you would have to emphasize the heterogeneity in your study. Now, as we mentioned, you can always consider what does this high statistical heterogeneity tell you? That means there should be additional things to explore. Maybe you want to do subgroup analyses with TACE with the drug-eluting beads, and always want to discuss the heterogeneity to maybe yield more hypotheses to generate more research going forward. And so then lastly, that brings us to the end of our second webinar for systematic reviews and meta-analyses. We talked about the importance of rating the quality of evidence, how to minimize biases in systematic reviews, and then we compared and contrasted qualitative and quantitative syntheses. And lastly, before we get to our final Q&A period, we would like to emphasize that you will be sent a survey. You will receive one after you leave this webinar. You'll also get one in a follow-up email tomorrow as well. You only need to fill it out one time, of course. It's very short. It only takes a few minutes. For those of you that complete the survey, will get a certificate of completion for the webinar. But please, when you click on Start Survey, you're going to see a drop-down list. From that drop-down list, please be sure that you select systematic reviews and meta-analyses from the list, because that will bring you to the questions relevant for this webinar. So with that, I'd like to thank all of you for your wonderful attention, and I'll be happy to take any questions that we have from the attendees. So I can see, so Hala mentioned to me she's having some technical issues. So let me read some of the questions I've seen so far. So one was, is there any site, for example, a university center, that researchers can join to receive learning in doing to be a good reviewer? Now, I'm going to answer that in two ways. If you mean a systematic reviewer, well, that's what you're doing here. But there's also online courses as well. I did recommend or emphasize the one from Cochrane Collaboration, although that one's not free. But there's also a lot of great handbooks from, like, for example, the Cochrane Collaboration or the Institute of Medicine that really provides a lot of fantastic information you can explore as well. If you mean peer reviewer, Nature Research Academies, we do have workshops. We do it for being a peer reviewer. And if that is something you think you would like to explore at your university, when you complete the survey and ask what other topics are of interest, please do select that one. And the EKB can organize it for the university. So let's see, any other questions? I think Hala is back now.
Yes, Dr. Jeffrey. We are now resuming the Q&A question session. So we answered the first question. So I will check if you have another question.
Wonderful.
Dr. Jeffrey, we have a question about the published raw data. If you can, the question is, the published raw data is a Mendeley are considered as published data or unpublished data? I'm not quite sure. Yes.
Sure. Mendeley is a reference database that a lot of people use to be able to usually collate more PDFs or articles rather than the data itself. But they may be referring to data sets that are available in data repositories online. But let me just clarify what I mean by published data. Published data means those that are have been peer reviewed. So in a peer reviewed journal. So we would not consider preprints as published data. We would not consider repositories or dissertations as published data. What we consider published data would be only those that have gone through the peer review process for a international or local regional journal.
Thank you, Dr. Jeff. And we have another question here. What are the differences between systematic and literature and meta-analysis review?
The main difference, so let me again emphasize that regardless if you do a systematic review or meta-analysis, you're always doing a systematic review. In other words, you're always going to do a qualitative synthesis to try to evaluate those studies, talk about the strengths, talk about the weaknesses, talk about any problems, confounding factors, any other issues that could lead to any issues in terms of data reliability, heterogeneity, but also to explore the patterns and trends across those different studies as well. That's a systematic review. The meta-analysis is then pulling that data together and recalculating the odds ratio for common risk ratio and presenting that as the average statistic for all of those different studies. And that's done in addition to the systematic review. So don't think that just because you do a meta-analysis, you don't have to do the qualitative synthesis. No, you have to do both. So you either do a qualitative synthesis, systematic review, or you do a qualitative synthesis plus a quantitative synthesis, which would be the systematic review plus meta-analysis. And that's why you'll see almost always in the title, the titles will either say systematic review or systematic review and meta-analysis, usually not independent of one another.
Thank you, Dr. Jeffrey. And the final question we have here about how to make a funnel plot.
How to make the funnel plot. So what you need to do is, well, first you're going to have on the x-axis, you're going to be then putting on the log scale your risk ratio or the odds ratio. And on the y-axis, you have your standard error, which is measure of precision. And again, keep in mind that the y-axis is the opposite. So 0 will be at the top, and the numbers get larger as you go down. So that means those studies you plot at the top, you plot the risk ratio, but you plotted them based on the y-axis on their standard error. Those larger studies with low variance will be plotted at the top. Those that are going to have low degree of or have higher degree of variance, therefore going to be less reputable, will be plotted towards the bottom of that funnel plot. So after you plot all of those different studies, then you visually assess, okay, does it look symmetrical or not?
Thank you, Dr. Jeffrey, and thank you everyone for your participation today and for your questions. And thank you, Dr. Jeffrey, for the very informative Q&As. Thank you so much.
My pleasure. I'd like to thank you very much, Hala, for wonderful facilitation of this webinar. And again, I'd like to thank everyone for their fantastic participation throughout these 2 webinars. It's been a pleasure working with you. And I'd like to hope everyone stays healthy, stays safe going forward.
Thank you so much for attending.